Hi everybody, this is Mr. Longo, and this video is going to cover special right triangles. Again, if you're watching this video, you should have already watched my video on the introduction to special right triangles, where it discusses all of these patterns. So, at the time of watching this, you should already know your patterns. So I'm going to tell you to pause the video and give as many of these questions a try as you can, and then we will talk about them when you're ready. So click play when you're ready to go after you give these a shot. Okay, so the first example, this is a 45, 45, 90. Now, as we've talked before in the other video, we should set up our pattern on the inside and take what you're given and set them equal. You are given that L is equal to 8. So anywhere you see an L, we're going to put an 8. So we should have 8 and 8 root 2 for our two sides. Okay? And if you want a little tip, bounce around. If you're taking a quiz or a test on these, do all of your 45, 45, 90s first if you'd like. So this would be L, L, and L root 2, and this would be L, L, and L root 2. And of course there's more. This is just what I have available on the screen for you, so we're going to do those. This one, we have L root 2 is given, and it's 7 root 6. So if we divide both sides by the square root of 2 to solve for L, we will get L is equal to 7 root 3. So both of these sides are going to be 7 root 3 because that's where L is. And this one over here, we were given that the L root 2 side is equal to 8. So to divide both sides by the square root of 2, we are going to have L is equal to 4 root 2. Again, remember, you cannot have a radical in the denominator, so you must rationalize it. And we get 4 root 2 and 4 root 2. Now again, that's just a little tip for you. You absolutely do not have to do that. But if it helps you, go for it. In our 30, 60, 90s, remember we have S, S root 3, and 2S. And I'm just going to go place those in all of my proper locations. In the other 30, 60, 90s that we're going to be working with, this one's missing a 30. Can't do that one without it. And we're going to then go use the pattern to solve them all. So going back to this guy right here, we were given that S is equal to 6. So if S is 6, this is a 6 root 3. This is 2 times S, so that's 2 times 6 is equal to 12. Okay? And for these over here, we were given the 2S is equal to 12 root 5. So we have to solve for S. So 2S is equal to 12 root 5. Divide both sides by 2. And S is equal to 6 root 5. So here's an S, so here's a 6 root 5. Here's an S root 3, so this is a 6 root 5 root 3, which simplifies to 6 root 15. Okay? And in this guy over here, we were given the S root 3 is equal to 15. Now we have to divide both sides by the square root of 3 to solve for S. Again, very crucial that you have good radical skills. 15 divided by the square root of 3 simplifies to 5 root 3. So if S is equal to 5 root 3, we have a 5 root 3 here, and 2 times 5 root 3 would give us a 10 root 3. Okay? So if you are struggling with these problems because you have no idea what I'm doing with the radicals, please make sure you stop this video and go watch the video where it covers how to work with radicals. So the last row, we have an L, an L, and an L root 2. We have our S, S root 3, and 2S. And we have our S, S root 3, and 2S again. So if you would like to try this row on your own, pause the video and then click play when you're ready to see how you did. So you were given L root 2 is equal to 11. So if you divide both sides by the square root of 2, you would end up simplifying that L is equal to 11 root 2 over 2. And since I said that we should not be doing decimals for this, we would have 11 root 2 over 2 and 11 root 2 over 2. Now, if you did 5.5 root 2, you are technically correct because it's not a decimal that repeats itself and goes all over the place. It's a nice, easy, exact decimal, but just get in the habit of trying to write things in a simplified fraction for now. Over here, we were given s root 3 is equal to 4 root 6. When you divide both sides by the square root of 3, we end up with s is equal to 4 root 2. So we have 4 root 2 for s and 8 root 2 when we multiply the 4 root 2 by 2. Okay? And the last one over here, we needed to divide both sides by the square root of 3. That would give you 7 root 3 over 3 for s and 14 root 3 over 3 for 2 times s. Okay? Now the last two questions are a little bit of an application. So we are given that the perimeter of a square, so we've switched to a square, but no fear, the special right triangles will help us out in this one because it has a square of 40 meters for a perimeter. That means each side is 10 because if we remember one thing about a square is that all 4 sides are congruent. So if we were to draw a diagonal here, what you should see is that we have just created a 45, 45, 90 special right triangle. So if you wanted to use the pattern, this is our L, and our L root 2. So the diagonal is just going to be 10 root 2 because it's just following the 45, 45, 90 pattern. Okay? And the same thing is going to happen with this last example here, and then we'll be done with this video. Is we are going to look for the perimeter of an equilateral triangle that has a height of 6. Now remember, a height is always vertical, or a height of 9, I'm sorry. So this guy is 9. Now you have to remember a few more things about equilateral triangles is not only are all 3 sides equal, but all 3 angles are 60 degrees. But if we draw on a height, it'll split it to 30 and 30. So again, this is just a 30, 60, 90 right triangle problem where we are given the height of 9. So that corresponds to our s root 3 side. So s root 3 is equal to 9. If we divide both sides by the square root of 3, we will end up with s is equal to 3 root 3. So this is a 3 root 3, and this is a 6 root 3. And if all 3 sides are 6 root 3, our perimeter is 18 root 3. Okay? So that's it for this video. This is Longo, and I'm out. See you, bye.